Hey everybody, today we're going to do section 8.3, and this is all about quadratic methods. It's what the textbook calls it. It's actually kind of interesting. It's the idea that we might be able to take certain functions and turn them into quadratics. That way we could factor them or use the quadratic formula to solve them or any of the things we know how to do. I'll give you an example first, just of what I'm talking about. So this one's not going to be tested, so just make sure you understand, not on test. This example, the other examples I'll do will be on the test, but I wanted to show you this idea. If I were to take something like x minus 6 equals the square root of x. This looks nothing like what we've been solving. You might try squaring both sides. Well, let's try that, because what's annoying about this is the square root, right? So what if I were to square both sides? That would get rid of the square root, correct? So let's see, if I squared this side, I'd have to FOIL this out. X minus 6 times x minus 6. And over here it would be easy because the x and the x squared would cancel. Or the square root and the square would cancel, leaving me with x. So if I FOIL this out, I'll get x squared minus 12x plus 36 equals x. And I could subtract the x over then, right? And if I subtract the x over, I'll have minus 13x instead of minus 12x. Then, if I know how to solve this, you notice that this is now a quadratic. It wasn't a quadratic before, but I was able to turn it into a quadratic, or kind of think about it as a quadratic. So then I can actually go about factoring and solving this one. And we know lots of ways to solve this. I could do the quadratic formula, which we covered last lesson, or I could see if it does factor. And actually this one I believe does factor. So we could solve it really quickly without the quadratic formula. Let's see. It would be minus 9 and minus 4, x minus 9, x minus 4, right? And then set each equal to 0 and solve them. But I don't want to spend a lot of time on this example, since this one's not the type we'll be testing you on. So x equals 9 and x equals 4. We should check those because we squared both sides. Remember, that can always lead to some sketchiness or some erroneous answers. So you might want to check it. If I put 9, let's see, 9 minus 6 is 3. Square root of 9 is 3. 4 minus 6 is negative 2. Square root of 4 is 2. So this one's not, we don't want to, this one's a bad one. But that type's not on the test. But that's just the idea. We'd like to see if we can make things look like a quadratic to use any of the methods that we've used before, whether factoring or quadratic formula. So these are the types that'll be on the test. So let me start with one of these. So x to the 4th minus 3x squared minus 4 equals 0. And you look at that, and the first thing I want you to notice is that this isn't x to the 4th. This is not a quadratic. But we're going to use a little bit of creativity to solve this. We notice that if this, let me just do a little bit of pretending or imagining. If this were a quadratic, this would be what it would look like, right? And we could try factoring this or the quadratic formula to solve this. But what's the only difference here are the exponents above the first x and this minus 3x. Notice the relationship here. These are just, well, first off, what's understood to be the exponent here is 1. These are just twice the exponents here, right? Does everybody notice that? So this is very, very similar to what we've been doing. It's just the exponents are wrong. So I do have a question for you. Let's ignore this. Can we factor this? Even though this is an x squared, x to the 4th and an x squared. And the answer is yeah, we actually can. Because remember, we're looking for something that'll multiply to give us x to the 4th. And here, the problem I gave you, x squared times x squared is x to the 4th, right? And then, let's see, what things multiply to negative 4 that add to negative 3? That would be a positive 1 and a negative 4. Now, FOIL that back out and check it. See if it does give you that. And I'll go ahead and spoil it for you. It will, because if you FOIL this out, you'll get x to the 4th, negative 4x squared, positive x squared, which will add to negative 3x squared. And 1 times negative 4 is negative 4. So that's pretty awesome. So the next thing we look for is, hey, well then do these factor further? And the answer is this one does. Notice this is a perfect square minus a perfect square. So a difference of squares. So this one will factor into x minus 2, x plus 2. This one doesn't factor. But that's okay. So I have 3 factors here. Can I set all 3 equal to 0 and solve? The answer is yeah, because I have it simplified down far enough. If I set all the factors equal to 0, I should be able to come up with all my answers, all my solutions. Now I'll go ahead and tell you something about this. I know how many solutions I'm going to have here before I even solve this problem. Because the highest exponent here is a 4, I should come up with 4 answers. Let's do these 2 easy ones first, and then we'll see if we come up with 4 answers. So this one, all I'm going to have to do is add 2 over. So there's one solution, x equals 2. Over here, all I'm going to have to do is subtract 2 over, so x equals negative 2. So there, I got 2 solutions, but you only see one more equation here. But wait, how would I solve this? This doesn't factor. You could use the quadratic formula, but what else have we learned? We've learned the square root property. I could subtract the 1 over. X squared equals negative 1, and then square root both sides. If I square root both sides, remember I have to count this as the both possible answers, positive or negative square root of negative 1. Now, square root of negative 1 is not proper to leave it that way, but we have some way of representing that. Isn't that just I? So x can be the complex number I or negative I. X can be the real number 2 or the real number negative 2. So how many answers do you see that that is 4, right? Positive I, positive 2, negative 2. So awesome. That's how we're going to approach these, because every one of these that I'm going to give you, including the one on the test, I'll make it so that the x to the 4th and x to the squared part, that it will factor like this. Okay? And then from here, you need to see how you can solve both of these x squared terms. Another way to do this, if you look in your textbook, is to do what's called a substitution, where you say, okay, well, this is x to the 4th, but I could make it look like x squared by saying, hey, that's x squared squared. And it confuses a few students looking at it that way. But that's one of the ways that they teach it in the textbook. But the style we're going to stick to is exactly like I did this one, because I'm always going to give you one that factors just for the level that we're doing this at right now. There's no need to kill you with this. So let's do one more example. Let's see. I'll go with x to the 4th minus 7x squared minus 18 equals 0. So I'm going to see if this factors. I told you I'd be polite and make sure it factored. X squared and x squared. So let's see, what 2 things multiply to negative 18 that add to negative 7? And I believe that's negative 9 and positive 2. Double check me. Yeah, that is right. Now, do either of these factor further? And oh, look, once again, a difference of squares. Perfect square minus a perfect square. So this one does factor further. I can factor it into x plus 3 and x minus 3. This one does not, because it's a plus sign. So that is okay. Sometimes you'll get something that might factor, but not super likely. So now I can set all of these equal to 0 and solve them. These 2 are really easy to set equal to 0 and solve, right? Hopefully you know those answers before I even take the time to write them. But I'm going to go ahead and write everything out. So let's do the easy ones first. Add 3 over x equals 3. Subtract 3 over x equals negative 3. This solution, let's just use the square root property. Subtract 2 over, and then square root both sides. But it'll be positive or negative square root, right? So x equals the positive or the negative. Now this is a negative 2, so I would like to, let's do a little scratch work here. If I'm trying to take the square root of negative 2, remember I can rewrite that as 2 times negative 1. I can give them each their own square root, their own radical. And then I can turn this part into an I, square root of 2, I. So let's do that. Square root of 2, I. So there are my 4 answers. Positive 3, negative 3, square root of 2i, and negative square root of 2i. So hopefully you don't find that too intimidating, even though it looks a little weird. But because we have this x to the 4th here, I'm getting 4 solutions. Whatever the highest exponent is how many solutions I should come up with. Okay? So that's one topic I want to cover today. I only have one other I want to go over. And it's the topic of something called the discriminant. Now the discriminant is just a piece of the quadratic formula. Do you remember we went over the quadratic formula just last lesson? And the quadratic formula is opposite b plus or minus the square root of b squared minus 4a times c over 2 times a. Okay? There's a special part in here. What's underneath the radical is the discriminant. That b squared minus 4 times a times c. That's the discriminant. Why do we care about the discriminant? Well, the discriminant tells us something about our solution. It's about our solutions. And here's what I mean. We can just glance that b squared minus 4 times a times c. If it's positive, that tells us something. If it's negative, that tells us something. And if it's equal to 0, that tells us something about our solutions. So if it's positive, we're going to get 2 real solutions. If it's negative, we're going to get 2 complex solutions. When I say complex, I mean it's going to be a complex number for our solutions. That's when we're talking about getting the I, because we're taking the square root of a negative. That should make sense, right? If it's 0, we're going to get 1 real solution. Okay? So we're just going to do a few examples telling how many real solutions or complex solutions I'm expecting to get. We're not going to actually solve these problems all the way. We're just going to look at the discriminant, and I want you to tell me how many and what type of solutions I'll have. So look at this one. X squared plus 2x plus 1 equals 0. So if I want to look at the discriminant, that'd be b squared. So remember, b is the number with the x to the first power. So 2 squared minus 4 times a. Notice there's no number in front of the x squared. That means our a is 1 times c, which is another 1. So let's see. 2 squared is 4 minus 4 times 1 times 1. Well, that's just 4. What's 4 minus 4 is 0. So what does that mean? Since my discriminant is equal to 0, that means that I will get 1 real solution. And since, you might have time on your hands, plug this into the quadratic formula, solve all of it, and see what your answer is. You will only get 1 real solution. It's kind of interesting thinking in that way. Let's do 1 or 2 more of these, and that's all we have for today. So another example, 3x squared plus 2 equals 0. Notice there's no b term. I could rewrite this in this way. Plus 3x squared plus 0x plus 2. Those are the same. Does everybody agree with that? So if I look at my discriminant, b squared, so 0 squared, minus 4 times a times c. So let's see, what's this going to be? 0 minus 4 times 3 is 12, times 2 is 24. 0 minus 24 is negative 24. So that's a negative discriminant. What does that mean? Well, that means we will get 2 complex solutions. Okay, so that's the answers that have I in them. Okay. All right, awesome. One more, and then we'll call it a day. One more. So let's look at 2x squared minus 7x minus 4 equals 0. And if I look at the discriminant, let's see, b squared, so negative 7 squared minus 4 times a is 2 times c is negative 4. So I'll put it in parentheses to be careful with it. Let's see, negative 7 squared. Notice it's in parentheses. That'll give us a positive 49. And I'm going to have minus, and all of these things have one negative. So it's going to be minus a negative or a plus. 4 times 2 times 4. That'll be what? 32? Whew. Now, adding these together, 49 plus 32, what is that going to be? 80, 81? Check me on that. I'm not really worried about that too much because it's definitely positive, right? Even if I made a mistake adding, a positive plus a positive is a positive. So that means we'll get 2 real numbered real solutions, like 7 or 19.2 or whatever. So you should plug that into the quadratic formula and see that you do get 2 answers. They may be nasty, they may be decimals, they may be beautiful, but you will get 2 real number solutions. And that's all I have for you today. So remember to do the worksheet, check your answer keys, and email me any questions that you have.